units and measurements. So in units and measurements, now if you take any physical term, you can say length or volume or velocity, whatever it might be. So without measuring, we cannot able to say we call a physical quantity. A physical quantity can be measurable. So a physical quantity can able to see, can able to observe, can able to sense it. So generally, so what is the meaning of physics? First point. What is the meaning of physics? Say, I say length. So length, it is having mass. Without mass, there is no length. Without mass, there is no length. You say anything. Acceleration. So acceleration, if you are going to say, what is acceleration? Velocity by time. Velocity by time. So what is the velocity? Displacement by velocity is displacement, I can say d. Displacement by time divided by t. So what it is going to get? Displacement by t square. So all these. So if I want to say displacement or distance, you should, without mass it is possible in length. Is it possible without mass length? Not possible. So mass lekunda length undadu. It is not possible. That means, so physics mass is the most important. Without mass, is there any physical quantity or any quantity in the universe? Unda. Mass lekananda unda. So okay sir, you say electron. So what is the electron? The charge of one electron, the mass of one electron. What is the mass of electron? I can say m suffix e. Mass of electron is 9.1 into 9.1 into 10 to the power of minus 31. What is the mass of proton? The mass of proton is 1.6 into 10 to the power of minus 27. What is this? Kg. That means smallest also having a mass in there. Understanding? That means there is no massless quantity in the universe. If there is something, that means the mass is there. Understanding? So that means when the mass is there, energy is there. When the mass is there, energy is there. So when the mass is there, energy is there. So that means E is equal to, what is the E? E is equal to mc square. This is given by who? Einstein's energy equation. E is equal to mc square. So here the mass is there. Where c is the velocity, m is the mass. Where m is equal to mass and c is equal to velocity of light. Velocity of light. So what is the velocity of light? 3 into 10 to the power of 8 meter per second. 3 into 10 to the power of 8 meter per second. Now, by observing this, so that is E is equal to mc square, mass is there. If you take any quantity, which is having a mass is there. That means, if you have a quantity there, it is having energy there. So that means, the study, physics means the study of energy or the study of nature is called physics. The study of energy or nature means what? Surrounding. So, if you say this is a pen, so is it a pen having energy? At present, what energy it is having? A energy only put present. Because of keeping height from the floor to here, this is having a potential energy. Potential energy. If there is no mass, no energy. Because mass is there, energy is there. Now once it is going to fall down, this is called kinetic energy. So position is potential energy. Once it is falling, it has a kinetic energy. That means energy there. That is the study of energy is called physics. But then after once you know this, how many physical quantities are there? First one, there are two quantities in physics. One is called fundamental quantity, fundamental physical quantity. Second one is called derived physical quantity. So entire physics, if you are going to see NEET or JEE Main, any competitive examination, so physics is the easiest subject when you know the units and measurements with their units. So it is the easiest one which I can make you the physics easy to get minimum 120 marks in our short term, I'm telling. In our short term, 120 marks I'll give you, which I'm having 30 years experience. I know what to do. So what are the, how to do the calculations. So without, from especially this topic, especially the topic, you are going to get minimum 5 questions. Minimum 5 questions, or all questions are based on the topic only. All questions, all questions are based on this topic only. Okay, na? Now coming to right. So write all of you definition. The what you call, what the definition I can say? The definition is what? So physics means, physics is nothing but the study of physics, the study of energy, the study of energy or nature, means surrounding, study of energy or nature is called nature or surrounding also, you can say whatever. Nature is called physics. Okay. Now in physics there are physics, or you can say science. In physics or science, there are two quantities. Okay. Number one, first one is fundamental physical quantity. Write all of you. Fundamental physical quantity. Physical quantities. And number two, derived physical quantities. Number one is derived, D-E-R-I-V-E-D, derived physical quantities. See, daily we are saying, but we don't know. Daily we are saying, but we don't know. There is a thing here, master thing. So, truly speaking, daily we are saying, but we are not able to identify, oh, this one. That. So, now we can see, so first one, fundamental physical quantity. So, fundamental physical quantity. So, every time we are seeing that the basic is a random error, systematic error, and what you call say gross error. From there what question is coming, and units, dimensional symbol or dimensional formula you are asking, match the columns are asked. Okay. Now first we can make it to first one, fundamental physical quantities. Fundamental physical quantities. But we are seeing daily, we don't know what is. That is a big issue. That's why physics is easy. So what is the definition of this one? The physical quantities which are independent are called fundamental physical quantities. All of you right? The physical quantities which are independent are called fundamental physical quantities. Now, complete all of you? Now, my question is, are you independent or dependent? First point. Okay? So, you are dependent on your parent, your friends, your whatever that is all, your surrounding people. They are also depending on you. That's why myself, I'm a teacher, I'm a lecturer, I'm a dependent or independent. Can you tell? So myself, I'm a teacher, I'm a dependent or independent. So I'm also depending on you and also my children, my friends, my relatives. Okay, that is I'm dependent. Now, another question I ask you, tree there. Tree is a dependent or independent? So, tree required what? Photosynthesis. It required what you call say oxygen and carbon dioxide. So, that means what? It is taking oxygen and giving carbon dioxide gas. Means it depends on what? Without what is any tree there? No, that's why tree also dependent. Okay, that means all living things are dependent and non-living things are independent. So, for example, pen is there. This pen is a dependent or independent? So, it is a independent. It is not, see, you can write also, anybody can write. If you write, say no, don't write like this. So, that's why it is a independent. Okay, pen is independent. So, that is supposed to be, with this camera is also independent, not dependent. So, that means all non-living things are independent. So, in 1960, throughout worldwide people, previously only three fundamental quantities are considering and were developing the science. But as modern science goes on developing, then finally they got a problem, one place to another place, how we are going to do, the different unit names are there. So 1960 in Paris, so all worldwide scientists together sit there in Paris, they concluded that there are 7 fundamental quantities that we call, the system is called SS system. There are how many fundamental quantities are there? Yes, previously 3 there, mass, length, time only. So from 1960, then they are concluded. So you have to consider temperature also fundamental quantity and current also fundamental quantity, illumination of brightness also fundamental quantity, and substance or matter also fundamental quantity. So without fundamental quantity you cannot able to do. That is also that. Fundamental means without that it is not possible to live. No, you may say, sir, what is the use of the current? Without current is not possible. Yes. What is the current? Current I is equal to charge by time, the rate of charge flow. This is called a charge. One electron, what is the charge of one electron? 1.6 into 10 to the power of minus 19 coulomb. So, this is the coulomb. The charge lies always outer surface of body, any body. Suppose I am a human being. So, if you go to the electrostatics, so there is a force of attraction between 2 charges. So, if you take a pen also, charge is there. That means this is called a fundamental. Charge is a fundamental. Light also fundamental. Substance or matter, the unit is mole. Without that is not, without what you call atom, molecule, it is not possible. So, matter, this is also fundamental. So, temperature, without temperature, is it possible to do anything? So, that is fundamental, temperature is a fundamental. Mass, because without mass, so mass also fundamental. The mass is there, length also fundamental. But I want to measure these 2 things, it means all these things, what you call to say time also fundamental. So these things are not depending on any other quantity. That's why they are called fundamental quantities, and they are also called scalar quantities. They are also called scalar quantities. All of understanding? So now we'll write it, the names of this one, and We'll conclude this one. So what are the names are there? First one is mass, second one is length, third one is time, and fourth one is temperature, and fifth one is current, and the sixth one is luminous intensity or brightness and the last one is substance or matter. Seventh one is substance or matter. So these are these names in SI system only. Now for this what I am going to do here is, so what are the unit names, and we can make it into the form of a tabular form. We can make it into the tabular form. See here all of you. So tabular form I am going to make. Okay. This is my fundamental quantity name. Okay. Fundamental quantity name. I want to make it to do something, right? Right, sir. So I'm going to make it in the form of tabular form. So all of these are 7 fundamental quantities. Okay. Now you write a tabular form. Sorry, it is going to be erasing. Right. Now I will go to tabular form. All fundamental quantities are scalar quantities. All fundamental quantities are scalar quantities. All fundamental quantities are scalar quantities. Now I can write it as this is okay, sir. Right, no problem. Okay. Right. All fundamental quantities names are scalar quantities. Okay. I'll put a serial number. Fundamental quantity name. And we'll go to write unit name. Right? Unit name. And unit symbol. And the next one is a dimensional symbol. Dimensional symbol. Dimensional symbol. Right? Now let them see here. Right? Good. Now I'll go to continuation. Otherwise, if you want to see bold, okay, it is visible for your eyes. Yes, thank you. Right? Now, Now I'll go to right name is the mass unit is in SI system we are talking. So kilogram, full name I have to write kilogram. Don't put full stop, comma, anything. Length is okay. Unit symbol also write in parallelly. Kg. Don't put any symbol. Just kg. Don't put kg. Is not a kgs. In SI system is a kg. You should not write plural form. Now it is a diamond symbol is M is capital letter M and length is meter. Length is meter. Symbol is small m. Here is unit symbol is small m. Diamond symbol is capital L. Time second. So unit symbol is small letter S. Diamond symbol is capital letter L. Capital T. Temperature, Kelvin. Temperature Kelvin. So symbol is K. Here theta over R K. So nowadays they are using K only. So theta also diamond symbol. Current or electric current. Current is ampere. While writing full name, you have to write small letter. Suppose your name is Ravi. What you are writing? You are a scientist means you have to write RAV, small letters you have to write. If you want to show the scientist name, so symbol means capital R. If it's Srinivas, suppose there so many names are. So if they are really scientists, they have contributed something in the science, particularly some particular area. And okay, area lo mere discover chestunte the scientist. So Newton. So Newton did a lot of research on what you call force, on mechanics. That's why his name is Newton. Scientist name is force unit is Newton. He did a lot of force. So, work on force, gravitational force. So once the force, you know what? Next work, you know. Force into perpendicular is called work. Work is nothing but energy. So work is nothing but torque. Turning force is called torque. Couple, rotating force is called couple. So that's why his name is symbolically for the remembrance of గుర్తుపెట్టుకోవాలి కదా. ఇప్పుడు మనం ఏం చేస్తాము, ఒక రాజకీయ నాయకుడి పేరు లేదంటే ఒక మంచి ఏరియాలో డెవలప్ చేసిన పేర్లు పెట్టుకుంటాం. ఓకే, అండర్స్టాండింగ్. కాబట్టి సో సైంటిస్ట్ నేమ్స్ ఫర్ ది రిమెంబరెన్స్ ఆఫ్ సైంటిస్ట్ నేమ్స్. సో వీఆర్ యూజింగ్ ద derived quantity names as scientist names. So current is charge by time calculator. Okay, current is ampere. So here is the unit symbol is A, diamond symbol is I. Sometimes they are going to show A also. So right. Luminous intensity candela. Candela, brightness candela. This is called as CD. Here also CD. So next, coming to this one, substance or matter. You can write MOLE, mole, molecule. The unit symbol is mole, MOL, mole. Diamond symbol is small, MOL only. Right? Next, what happened? This everything is discussed and finalized and all went to their places. Again they got it out. So what about the geometry? How to do this one? Then planes, geometrical measurements, they got it then. So again they called it back. So they introduced two other names. Those are called supplementary quantities. Those are called supplementary. How many supplementary quantities are there? There are two supplementary quantities. So those are supplementary. So in suppose some students supplementary quantities. So 2022 one question asked from supplementary quantities. So people are neglected this one. This is the most important topic. Without this, no physics, no science, nothing is not there. All of understanding? All 45 questions, without unit, no physics is not there. Without unit, no physics, solution is not there. After solving, you have unit there. That's why ఫ్రమ్ దిస్ టాపిక్ ఐ సే లిటరలీ నేనేం చెప్తున్నానంటే 5 క్వశ్చన్లు వస్తాయి. ఇంకా మాట్లాడితే 11 క్వశ్చన్లు 11 క్వశ్చన్స్ చేయొచ్చు. దట్ మచ్ డీటెయిల్ ఐ గివ్ యూ. అండర్స్టాండింగ్? 11 క్వశ్చన్స్. లాజిక్ ఇఫ్ యూ ఆర్ యూజింగ్ you can get 11 questions. No need of chapter. I'll give that much detail. Okay na? I'll give that much detail for while you are going to derive quantities. I'll give that much detail. So that is related to directly topic. It's called application. I'm going to do application in units. Okay, and measurement step. So coming to these 2 quantities, I can write it. So they are called supplementary quantities. One is called a plane angle, and it is called a solid angle. All of you knows. So in supplementary quantities, what I have to remember is there is no dimension symbol. Only units are there. 2022 they asked. How is happening? So first one is plane angle. Plane angle. What is the unit of plane angle? Radian. Full name I am writing RADIAN. Radian. Unit name rad. RAD, rad, small letters. So no dimension symbol. Second, last one, solid angle. Solid angle. So steradian. 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 Small letter only. Steradian. SR. S suffix R. No dimension symbol. Okay, so this is the what you call derived fundamental quantity names. So these fundamental quantities names also called scalar quantities. So how many fundamental quantities are in SI system is 7 only. Don't add this 2. So sir, 2 plus 7 plus 2 9. No. They called supplementary quantities. Supplementary quantities. So these are 7 fundamental quantities in SI system, and those are scalar quantities. Okay, and from plane angle and solid angle are supplementary quantities that have no dimension symbol but units are there. So angular velocity. So angular velocity dimension symbol is t to the power of -1. Angular displacement by time. Just I'll give a small example, then we today we'll close it, and then next class we'll continue. So angular velocity, all of you copied? Okay. Thank you. Then I'll give a small example for this one. You can feel comfortable. So angular velocity, angular displacement. Sir, angular velocity I can choose. Angular. My question is angular displacement. Have you seen angular displacement? By time. Have you seen angular displacement? Yes. So what is that? Rotation. Suppose I am going to here is I am going to rotate it. So this is my instant. Then I start to rotate. It's called angular displacement. So this is the you take as you are going to be moving around a fixed point in circle. So this is my circle rotation. So this is my initial position. This is the center O. The initial position A. Then final position is B. So take this is the radius. So this is the radius of R. This is the displacement. How much angle? Theta. Angular displacement. How much time is taken? What you call, if you say dt, that is a d. It is d theta. Then time taken is dt. What is that? So that's why. So for angular displacement, listen all of you, very simple. So daily seeing, but we don't know, that is the problem. Okay. So angular displacement is no dimension symbol. So time is t. So therefore the dimension formula of this one is so t to the power of -1. So what is the mass? Unit mass. M to the power of 0. Anything to the power of 0 is what? 1. What is the length? L to the power of 0. 1. So this one. This is called dimensional symbol. I can short form, I can write it as DMF. I can call it as. Okay. I call it as DMF of angular velocity. But what is the unit? The unit is what? So angular displacement unit is there, that is called rad per second. Rad per second. Okay na? So dimensional is the unit is one. So thank you.